Tornado. Even the word communicates a tingle of excitement, a sense of awe at the extraordinary forces of nature unleashed from time to time, often without warning. Scientists study the tornado, hoping to understand one day the source of its remarkable energy and power. A concentrated spiral of wind, and often water, capable of lifting solid objects of great size and weight, carrying them far into the air only to be deposited in some distant place. In part, it was out of this natural phenomenon that the idea for a revolutionary new pumping technology was born, the eddy pump. In an exciting departure from conventional centrifugal pump design principles, the eddy pump is conceptually based on the ability of the pump rotor to both create and harness a dynamic fluid eddy effect within the pump housing and inlet. Indeed, the phenomenon closely resembles that of the tornado, or better, a waterspout. A spiraling column of fluid of immense energy, passing down through the housing and through the hollow center of the intake. This rotor-induced synchronized column of fluid agitates the material to be pumped, sand and gravel, silt, or sludge, for example. This powerful swirling column of fluid creates a peripheral eddy effect, causing the agitated material to travel up along the sides of the intake chamber by reverse flow, up into the pump casing. Here the material, by centrifugal force and under positive pressure from below, passes directly into the discharge. The eddy pump is unique because it stands apart from conventional centrifugal pump design and operating dynamics. The eddy pump operates without experiencing the net positive suction head or NPSH-related performance difficulties and limitations common to conventional centrifugal pumps, such as cavitation, vibration, and the inability to effectively pump high viscosity, high percent solids, and high specific gravity material. The revolutionary eddy pump rotor, operating at speeds up to 2,000 RPM without cavitation or significant vibration, produces a continuous downward swirling flow force, creating turbulence and suction at the pump inlet. Suction force of the eddy pump occurs at the pump inlet throat, not in the pump volute, as is the case with conventional pumps. This results in important advantages. The rotor itself does not require critical clearance tolerances of wear plates to be efficient. Thus, rotor life far exceeds that of conventional impellers. The blue column represents graphically the eddy pump's tornado force, the transfer and actual amplification of energy from the rotor to the mouth of the inlet. At the inlet, peripheral eddy effects agitate the material, causing it to rise at great velocity. This action often eliminates the need for a cutter head in the majority of applications. This feature makes the eddy pump ideal for removing contaminated sediments, in waterways, for example, where resuspension of material by a cutter head or dragline bucket would be potentially damaging to the environment and unacceptable to environmental authorities. Because of its revolutionary design, the eddy pump will pump solids of high specific gravity, high viscosity, and high aggregate content. In over 5 years of development and field testing, the eddy pump consistently pumped sand and gravel, mineral slurries, and other high solids materials in percentages 3 to 4 times greater than conventional pumps. Many early field trials of eddy pump prototypes were in dredging applications. The first of these took place in 1987 in Louisiana. Mounted on a conventional dredge with the cutter head disengaged, an 8-inch eddy pump pumped hard-packed blue clay in quantities comparable to a 12-inch dredge, according to on-site observers. It was found the compacted clay was converted to a jelly-like puree under the force of the pump. Further testing confirmed these early findings. In tons per hour, an 8-inch eddy pump will generally handle volumes comparable to a conventional 14-inch dredge pump. In most applications, supplementary agitation, such as hydrojet or cutter head, has proven unnecessary and generally been abandoned. In some clay tailing ponds, An 8-inch eddy pump will pump a slurry of less than 5% free water at 60 to 70% solids, a nearly impossible task for conventional pumps. In applications where impact damage to the rotor is a concern, the eddy pump rotor can readily be recessed with little loss of efficiency. In most cases, spherical objects or other debris of up to 1 inch smaller than the diameter of the pump intake will safely pass through the housing to exit the discharge without interruption of flow. Rags, string, plastic bags, and other foreign materials known to stall conventional pumps will generally pass through without fouling the rotor. Where desirable, the rotor will act as an effective chopper of such material. EDDY 1, a custom-designed 8-inch dredge built by San Diego Gas and Electric Company in 1989, pumped over 250,000 tons of fine silica sand in the fall of 1989 with no appreciable downtime and with no significant wear to the pump casing or rotor. As with earlier efforts, volumes averaged 400 to 500 tons per hour, the percentages of solids in the range of 45 to 70%. The eddy pump proves to be extraordinarily effective in pumping organic materials as well. And a full season's pumping under contract with a major metropolitan wastewater treatment agency, EDDY 1 successfully pumped 13.8% dewatered sludge at an average rate of 2,800 gallons per minute, with discharge distances ranging up to 1,380 lineal feet. In one 8-hour shift, the EDDY 1 dredge registered nearly 1.4 million gallons of sludge. Transport trucks of 20 to 29 cubic yards, traditionally loaded by dragline in 10 to 14 minutes, were filled by the eddy pump in 1 to 3 minutes, with no spillage or overflow. Crane-mounted submersible and hydraulically driven 4- and 6-inch eddy pumps have been used successfully in pumping highly viscous, often abrasive chemical industrial waste products, sludge and mud. Reports of these activities have received enthusiastic coverage in professional journals and trade publications distributed internationally. Further applications are presently being investigated: coal slurries, petrochemicals, including oil spill cleanup, hard rock mining, industrial and toxic waste treatment, chemical and food processing, and paper pulp are most frequently mentioned. In this era of niche marketing, the eddy pump will be hard to confine. For the eddy pump is not merely an improved centrifugal pump. Recognized in patents secured in the United States and around the world, the eddy pump synchronized flow design principle introduces an entirely new dynamic pump classification. Simply stated, the eddy pump. Put the tornado to work for you.